Okay, hello biologists. The purpose of this video is to take you through setting up your spreadsheet for the Hardy-Weinberg lab. I'm going to try and make this about 15 minutes worth of work or so on my end. It may take you a little longer. You might need to go back, rewatch, double check things, and if you get stuff, just let me know. Okay, I'm happy to help. Okay, I'm going to share my screen back to, I got lost. Okay, here we go. Back to the lab manual. And we're down here on step 4, on page S30. Okay, so spreadsheets are a super useful tools we talked about in the last video, and also they make doing math easy peasy. They do it all for you. They repeatedly can make a calculation, and they can do that based on other calculations. And they also, all of them have random functions that allow us to include the randomness of everyday events in there. So we are, I'm going to start with opening a new Excel spreadsheet, and I'm going to do this using Microsoft Office. So the nice thing about starting it in Office 365 is that it saves it for you, and it's going to be in your Office 365 instead of being on your desktop or somewhere else where it can get wiped. Again, if you're doing this in Google Sheets, everything's going to be very similar. There will be a couple of things that'll be different, and I don't know what those things are because I hate Google Sheets, so you're on your own. So if you have an AP Biology folder, that's a great idea to put this in. If not, at least open an Excel spreadsheet here. I'm going to do a new blank workbook. And I'm going to name it, okay? I'm going to name it Hardy-Weinberg Lab. I'm just going to click up here on book, Hardy-Weinberg. Okay, and this way I can find it because it's going to be in my Office 365 and I should be able to find it easy peasy. Okay, so let me set this up so I can move back and forth between my tabs a little easier. Oh, look at that. Okay. Okay, so I'm going to toggle back and forth between this lab book and between my Hardy-Weinberg spreadsheet. Okay, so the first thing it says to do is let's define a couple of variables. Let P equals the frequency of the A allele and let Q equal the frequency of the B allele. So it's going to make things clearer to use A and B, but it also makes things initially a little bit more confusing. But just keep in your mind A equals P and B equals Q. And in fact, let's put it right here on our spreadsheet and have it say that P equals A and B equals Q. So I'm going to go to my spreadsheet and I'm going to go down to cell 2. I'm going to keep row 1 open. And I'm just going to say P equals, and then I'm going to hit tab to go to the next row. And I'm going to type frequency of, and what did they say? Okay. And then I'm going to hit tab to go to the next cell. I'm going to say E equals, and I'm going to initially set it to be 0.6. Okay, so this means that 60% of the alleles in my population are A, and this is the dominant allele. In my next row down, I'm going to go Q equals, and I'm going to hit tab. I'm going to say frequency of, and I'm going to type B equals. Okay, and I'm not going to type in 0.4 for reasons that will become apparent. Now, the spacing of these boxes is kind of funky. So if I just hover in between the A and the B until I get this little double line with the double arrows and I double click, it automatically makes the width of that column the width of my text, which makes it look nicer. So I'm going to do that again. Now you can see frequency of A equals B equals. Okay, so I do not want to type into B 0.4 because that way, if I change A to 0.7, B is still going to go to 0.4. And I'll have to do all the work to go back and change B all the time. I don't want to have to do that. I want my spreadsheet to do as much work for me as I can. So I'm going to give it the equation that will make it always adjust so that a plus b equals 1, because we know half the Hardy-Weinberg equation is p plus q equals 1. Okay, so I'm going to type in equals, and then I'm going to go up and click on that cell D2. No, I'm going to do 1 minus D2. Okay, so I typed in equal. It won't work if you don't do the equal sign. And then I did 1 minus, and then I clicked on that D2 cell. Again, I don't want to type in 0.6 because I want this to update for whatever it says in D2. And then I'm going to hit enter. Okay, and now it says 0.4. So play with this and make sure it works. If you type in 0.7 for D2, does D3 automatically update and say 0.3? And just to step back, I'm using the letters and the numbers to refer to this. If you ever played Battleship, it's the same kind of thing, right? Like here is E4 and here is G1, okay? So the letters on the top and the numbers on the side. Okay, so back here, if I type in 1, my B in cell D3 should be equal 0. Perfect. Okay, I'm going to do 0.5. It should say 0.5. I'm going to do 0.05 and it should say 0.95. Okay, so everything's working as I expect it to. And if yours isn't, it's probably because you forgot the equal sign. So make sure that in this cell it says equals 1 minus and then D2. And you can either type in D2 or you can just click that cell D2 to make that appear. Okay, next up. Okay, so we finished everything it said on page S30. Okay, so I'm gonna go ahead and type in the cells, shade the cells. Okay, and if you wish, shade the cells as well. This blue area will represent the gene pool for your model. Highlight the area you wish. Okay, sure, why not? Okay, the gene pool for my model. So remember, this is the individuals who's are members of my population who are contributing. I'm gonna just go to fill color. I'm going to make mine light yellow. You can make yours whatever color you want. These are super important cells and they're going to be foundational for the rest of our model, so making them a different color isn't a bad idea. Okay. This is a spreadsheet, so you can enter yada, yada, yada. We did that. Okay. So ours looks like theirs. And now see how they have the boxes around 0.6 and 0.4? I kind of like that. So I'm going to go put boxes around my 0.6 and 0.4. So I'm going to highlight this cell D2. And then see this little icon right here? This is my border icon. And if I hit the little caret, I can choose the different borders I want. I just want a straight up square around it. So I went to the one that looked like a square. I'll redo this for D3 for my B allele. I went down, hit the little caret next to the border function, and then just the one that says outside borders. Okay, and now mine are in boxes too. Okay, so let's explore how one important spreadsheet function works before we incorporate it into our model. In a nearby empty cell, enter the function, we'll remove it later, equals rand left parenthesis, right parenthesis. Okay, so I'm just gonna go over here, I'm gonna take in equals rand left parenthesis, right parenthesis, and I'm gonna hit enter. Whoa, give me a number, 0.864. To refresh my spreadsheet, I can hit F5. No, okay. What's the best way? I've never, oh, there it goes. Okay, so, and now it says 0.55. So one way to refresh your spreadsheet is to hit F5, and another way is just to hit the refresh button. Okay, I'm gonna hit F5 again. This reloads the whole page. Okay, now it's 0.32. So every time I refresh my page, it's going to give me a different number between the values of 0 and 1. Now this is advantageous because it's a truly random number that it gives me all the time, but this is a little bit tricky because it means that my spreadsheet can change all the time. If it's built on this random number, anytime I reload my sheet or do anything new to it, this number will change. So we'll figure out how to deal with that uncertainty or that randomness, just like there is in life, as we go through this model. I'm going to hit F5 one more time, refresh. Okay, now it's 0.08. So this is the random function. It's a random number generator between 0 and 1. Okay, so that is playing with the random function generator. Oh, F9. It says you can do F9 to do the recalculation. I wonder if that makes it refresh without reloading the whole screen. Okay, that's much faster. Okay, F5 is reloading the whole screen. F9 is just refreshing that cell basically. So I can go through a whole bunch of different numbers, random numbers between the value of 0 and 1. Okay, F9, follow their directions. Okay. It's a powerful feature of spreadsheet. It allows us to enter a sense of randomness to our calculation if it is appropriate. And here, since we're randomly choosing gametes, we definitely want that randomness. So we're going to go ahead and delete that rand function in that cell, and we're going to use it, harness it to give our random mating. Okay, so let's select 2 gametes from the gene pool. In cell E5, let's generate a random number, compare it to the value of P, and then place either an A gamete or a B gamete in the cell. We'll need 2 functions to do this, the rand function and the if function. Okay, so in E5, I'm going to type this in right here, just like it says. If random number, is less than the value in D2, click enter A, and if not, enter B. Okay, so I'm going to go do that in my Excel sheet in E5. E5, so equals if my random number is it less than or equal to? Let me go back and double check. Yeah, less than or equal to. Less than or equal to. Now, I'm going to do, instead of just clicking that cell D2, I'm going to do $2. And the reason for this is if I just click D2, the spreadsheet is smart. And if I like drag this formula down to the next cell, which I'm going to, it'll reference the next cell down from D2. I don't want it to do that. I always want it to reference that cell, or in particular, yeah. So it's gonna, that $sign kind of locks that in place. So I'm gonna do $2, $2, then type in A, and I need the parentheses so that it knows that it's a letter. And then if it's not less than the value of D2, then put in a B, parentheses B. I'm gonna close, oops, not the P, I'm gonna close my parentheses there. Okay, so this tells me so there's an if function here, and it says if the random value that it generates, and I'm not even gonna see that random value, it's just gonna be there. If the random value that it generates is less than the value in D2 right here, then put it in A. But if it's not, then put it in B, okay? So I'm going to hit F9 a couple times. It should sometimes say A, and it should sometimes say B. So I'm going to F9, A, F9, A, F9, B, F9, A, F9, A, F9, A, F9, A, F9, A, F9, A. Okay, there was a B. I was starting to get worried. Okay, and I can play with these numbers. Let's say I make my P 0.1. Well, I should expect to see a lot of B's and not a lot of A's, right? Because my A is 0.1, and so most times my random number is going to be greater than 0.1. So I'm going to hit F9, 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 F9. So that was a bunch of B's before I finally got this A. So it looks like my random function is working just fine. Where it's going to compare this random value to the cell D2, and if it's less than the random value, it's going to put it in A, and if it's greater than the random value, it's going to put in a B. So this allows me to get real randomness in which gamete I'm selecting from my gene pool. Am I selecting an A gamete or a B gamete? Totally random based on the random number that's generated. Okay. So the formula in this cell basically says that if a random number between 0 and 1 is less than or equal to the value of P, then put it in A, or if it's not less than or equal to the value of B, put in a B gamete into the cell. If functions and rand functions are very powerful tools when you're trying to build models for biology. Now create the same formula in cell F5, making sure that it's formatted exactly like E5. Okay, so we're going to do the same thing, and this is where a lot of students make mistakes at. So I'm going to go over here to F5, and I want it to be the exact same. So equals if rand, left parenthesis, right parenthesis, less than or equal to P. I'm still referencing P. I'm not going to reference Q. So that's an error that a lot of students make. And remember, I just made a mistake, right? I clicked D2. That's going to make it update. I don't want it to update. I want $2. Okay, so I can go in and pop my $sign in there. Then type in A, and if not, then type in B. So this is the exact same function, It's going to reference P, and it's going to say if my random value is less than my value for P, put in an A, or otherwise put in a B. Now I could have, no, I'm not even going to say that. Okay. So let's go back and look at our spreadsheet there. We're going to press F9 a handful of times and make sure that these are both changing. So F9, 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 F9. So you can see that the offspring produced by these two random selections out of the gene pool are going to vary because it's based on a random function generator. So it really is random. Now I got a B and an A. Now I got an A and a B. Now I got an A and an A. Now I got an A and an A. Now I got a B and a B. Okay, so yours should be working like that. If not, go back and watch this and double check that your formula looks exactly like mine. You need the parentheses, the dollar sign, the comma, everything has to be the exact same. It's really easy to be off by one character. Okay, let's try recalculating 10 to 20 times. I do that by hitting the F9 key. I know it's different in Google Sheets. I don't know how it is. Maybe you just have to refresh the whole page. I can't remember. Are your results consistent with what you expect? Do both cells E5 and F5 change to A or B in the ratios you'd expect from your p-value? So how about if I change my p to 0.9? Okay, now I'm going to expect lots of AAs, some ABs, and very, very few BBs. So I'm going to hit F9, 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 F9. So I had an overwhelming majority of A's, but I did occasionally get a B, and that happened in both E5 and F5. So, shoot, Control Z. Okay, I accidentally typed in 0.6 into my frequency for B, which is not what I want. I want to do that for A, and then B automatically updates itself. Control Z is your friend. Okay. Okay, and I'm going to label these as my gametes, because that's what they are. They're my gametes. Yep, wrong cell. Okay, so I'm going to write up here, I'm going to do gametes. And they made theirs look really nice. And they did this by merge and center. So this is merge and center right here, this button. And that puts my gametes, this word gametes, it merged those two cells together. So it's one. And they also put the nice underline underneath it. So I'm going to do that too with my borders. And they made it bold, which I think is nice because it's super important. Okay, so now my gametes look just like their gametes, and the A and the B. Differences, mine are a little bit wider. Maybe I want to make mine a little narrower like theirs are. 5.29, do this the same on both sides. Make it exactly 42 pixels wide. Okay, that looks nice. I'm going to go with that. You don't have to do that. Okay, that's figure 3. You could stop here and just have the computer recalculate over and over, similar to tossing a coin. However, with just a few more steps, you can have a model that will create a small number or large number of gametes for the next generation, count the different genotypes of the zygotes, and graph the results. That's what we're doing. So copy these two formulas in E5 and F5 down for about 16 rows, to represent gametes that will form 16 offspring for the next generation. Okay, so I'm going to go back to my sheet. And the easy peasy way to copy cells is I'm just going to highlight these two cells, this A and this B. It should be the kind of highlight that has the green box around them. And then I don't want the big white plus. I want it to hover right over this corner. See how there's this little green square right here in the corner? I want to hover over that until I have the black plus. And when I do that, I can drag it down and automatically fill those cells. So how many do I have? 1, 2, 3, 4, I lost count already. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh my gosh, it was 16 exactly. So if you drag it down to 20, that gives you 16. Okay. So if you didn't get that, watch that again. You don't want to go back and retype all this. Make the computers do the work for you. Grab it in the corner right here. Hover over that little green square in the bottom right hand corner until you get the black plus. Click and drag it down. Okay, and then hit F9 to make sure nothing broke in your dragging. All of them should update just like they were before. And since I have my P set at 0.6 again, I should have slightly more A's and B's. So everything looks good. Everything's shifting just fine. Okay, we're almost at a stopping spot for today. I want to go ahead and take these gametes and put them together to make the zygote. So we'll put the zygotes in cell G5. The zygote is a combination of the two randomly selected gametes. So egg and sperm come together and make one egg. That's called the zygote. In spreadsheet vernacular, you want to concatenate, I always say that wrong, concatenate the values in the two cells. So I'm going to enter this formula into the cell G5. Concatenate, and those two cells with a comma in between them. Okay? Concatenate, and it always equals first. So equals concatenate, and then I'm just gonna click, comma, click, right, parenthesis. Okay, and I'm gonna hit enter. Okay, and it put them together, right? I had an A, and I had an A, and now I have an AA together. And that's exactly like, this is the spreadsheet version of reproduction. You take one gamete and one gamete and you just smush them together, okay? And I'm gonna hit F9 and make sure that as my gametes change, my zygote changes as well, okay? When it's AB, it says AB. When it's, okay, when it's BA, it says BA. Okay, I'm gonna, again, click on this cell until and then find that green square in the corner, hover over it until I have the black plus, and then I'm gonna drag it down. Okay, and my concatenate looks like it works, because look, AA, BB, and if I hit F9, it changes, and my concatenation also changes. God, that works so well. Okay, and I'm gonna go ahead and label that zygote. Okay, I'm going to extend my underline under it. I'm going to bold it so it matches my gametes. And I'm also going to align it down the middle because I think it makes it look a little nicer. In fact, I want all my letters aligned down the middle, so I'm just going to go up here where it says EFG. I'm just going to highlight those three by clicking on them, and I'm just going to hit this little center button, and then it looks nice. They're all lined up down the middle. And you could color code these. It looks like they do here on their version. It looks like they make the gametes light green, the zygotes light yellow. If that helps you, go for it. I think it's going to get a bit excessive to do that, so I'm going to use my highlighting a little more selectively. Okay, so we're going to do some things with these gametes, but I'm going to stop here for this video. If you made it this far, if your spreadsheet looks like mine, you are in awesome shape. All right, so looking forward to the next part. Control S, wait, before I sign off, Control S. Save it, even though we're in Office 365, just to be on the safe side. Okay. Looking forward to the next part of working with this model with you soon. Stop share and record.